In this lesson, we are going to be talking about graphing exponential functions. So let's start with a specific function, f of x equals 2 to the x power. The base of our function is 2, and the variable x is up in the exponent. That's what makes this an exponential function. Making a table of values, we're going to plug in the numbers -2, -1, 0, 1, 2. 2 to the -2 power is equal to 1/4. 2 to the -1 power is equal to 1/2. 2 to the 0 power is equal to 1. 2 to the 1 power is equal to 2. And 2 to the 2 power is equal to 4. So we have now these 5 points to give us our basic shape of our function. And I'm just going to label the points 0, 1, 1, 2, and -1, 1/2. You notice that our graph starts out really flat on the left and then increases quite fast. If I plug in 2, the output is equal to 4. Y equals 0 is a horizontal asymptote. The farther that we go out to the left on this function, the graph stays positive, but it gets closer and closer to 0. A basic exponential function looks like f of x equals b to the x, and if b is greater than 1, it's going to be an increasing graph from left to right. But it still has 3 basic points that are the same. If we plug in -1, the output is 1 over b. If we plug in 0, the output is 1. And if we plug in 1, the output is whatever the base is, b. And the graph is increasing from left to right. So every exponential function where the base is greater than 1 has this same shape, where it increases from left to right, has a horizontal asymptote at y equals 0. But what if the base is less than 1? So let's look at f of x equals 1/2 to the x power. We're going to plug in the same x values, -2, -1, 0, 1, and 2. 1/2 to the -2 power is equal to 4. Remember, negative exponents give us the reciprocal. If I plug in -1, the output is 2. If I plug in 0, the output is 1. Plugging in 1, the output is 1/2. And if we plug in 2, the output is 1/4. You may notice that these are the same numbers, just on the other side. It looks exactly like our other picture on the last slide, just reflected over the x-axis, the y-axis, a horizontal flip. Passes through the point 0, 1, 1, 1/2, and -1, 2. Y equals 0 is our horizontal asymptote. So this is the shape of a basic exponential function where the base is between 0 and 1. The graph is decreasing from left to right. it passes through the point -1, the reciprocal of b, 0, 1, and 1b. Same basic shape, decreases from left to right. So in general, if f at x equals b to the x power, 3 points that the graph will go through is -1, 1 over b, 0, 1, and 1b. And y equals 0 is a horizontal asymptote. When the base is greater than 1, the graph is increasing from left to right. And when the base is between 0 and 1, the graph is decreasing from left to right. Let's look at a not so common base. Let's look at f at x equals 4/3 to the x power. The 3 points that we have on the graph are -1, 1 over 4/3, but that's the same thing as 3/4. -1, 3/4. When we plug in 0, we get 4/3 to the 0 power, but a base raised to the 0 power is always equal to 1. So we have the point 0, 1. And if we plug in 1, we have 4/3 to the 1 power, which just equals 4/3. Oops. Didn't write that correctly. Plug in 1, the output is 4/3. And then we're going to connect the dots. Notice that our graph is increasing from left to right, and that's because my base, b equals 4/3, is bigger than 1. And y equals 0 is our horizontal asymptote. Anytime you are asked to graph an exponential function, this would be the starting point. What are the points? 3 points that it passes through, and what is the horizontal asymptote? Now let's graph f at x equals 2 to the x plus 1 power minus 3. Now we are going to be using transformations. My parent function is y equals 2 to the x. And we know what this graph looks like. It's an increasing graph from left to right, passes through the points 0, 1, 1, 2, and -1.5. And y equals 0 is a horizontal asymptote. To graph y equals 2 to the x plus 1, the exponent is an x plus 1, which means I added 1 to the input, which means the transformation is a shift left by 1. And then when we look at 2 to the x plus 1 minus 3, this is a shift down by 3 because it's after we did the exponential function. It's on the outside of our function. So we have a horizontal asymptote at y equals -3 because we're shifting down 3. Moving each of our points, where does the point 0, 1 go? It goes left 1, down 3. to the point -1, -2. The point 1, 2 goes left 1, down 3, which ends up at 0, -1. And the point -1.5 would end up at -2, -2.5. Connecting the dots, we are increasing from left to right. And here is my horizontal asymptote at y equals 3, -3. Y equals -3. Doing one last example together, let's graph f at x equals 3 times 1/4 to the x power. My parent function starts off with y equals 1/4 to the x. And this is a decreasing exponential function, passes through the point 0, 1, 1/4, and -1, 4. The horizontal asymptote is y equals 0. And then if we're looking at 3 times 1/4 to the x, this is on the outside of the exponential function, so it is 3 times as tall. It's a vertical stretch by a factor of 3. So instead of passing through the point 0, 1, we go through the point 0, 3. We go through the point 1, 3/4, and -1, 12. And I'm not really drawn to scale. I kind of ran out of room. But you'll get the idea. It's 3 times as tall. And y equals 0 is still our horizontal asymptote, because numbers that are close to 0, when you multiply by 3, we're still very close to 0. So again, here are the basic ideas for exponential functions. Passing through the points -1, the reciprocal of b, 0, 1, and 1b. And y equals 0 is a horizontal asymptote. When the base is greater than 1, we're increasing from left to right. And when the base is between 0 and 1, the graph is decreasing from left to right.